In this hands-on, we're going to explore the concept of partial functions in practice. Let's start with our first example in streaming log processing. Here we're looking at a simple function called process_log that formats log messages. In a typical log processing scenario, you might have different log levels like error, info, or debug. Instead of specifying the log level every single time, we use the partial function imported from the functools module that allows us to preset some of these parameters. In this case, we create a new function called error_log that is a version of process_log with the level already set to error. This makes it easier and more efficient to log error messages as you don't have to specify error every single time. Moving on to genome pattern recognition, the function find_pattern searches for a specific DNA pattern within a sequence. By using partial functions here, we can create a new function called find_ATG_pattern that is specifically tailored to look for the ATG pattern using find_pattern. Moving on to stock price anomaly detection. This third example is about detecting anomalies in stock prices. The function detect_anomaly determines if a given price change is significant based on a threshold provided to the function as an argument. We create a partial function called anomaly detection that has a preset threshold value of 10 in this case. As with the previous use cases, this can be particularly useful in financial analysis where certain threshold values are commonly applied to multiple data points and needn't be repeated if a partial function can be composed with them instead. Now that we've built a bit of intuition around how partial functions are being used in practice, let's go through some likely real-world use cases. In streaming log processing, for instance, we can create more advanced partial functions for different log levels and formats. The function advanced log in this case can be set up for different scenarios using partial functions, such as error log short, error log long, and so on. For genome pattern detection, we can extend the concept to search for multiple patterns simultaneously. The partial function common pattern search can be used to check for several patterns in a sequence, leveraging the new find multiple patterns function over here that accepts a sequence and a list of patterns to check against that sequence. Finally, in the context of stock price anomaly detection, partial functions can be tailored for specific detection strategies, such as absolute change or percentage change criteria, as is implemented here in this example. We have a function here called real-world anomaly detection that's accepting a few arguments, these being price change, percent change, the absolute threshold, and the percentage threshold. A new partial function is then created using this real-world anomaly detection function with prefixed values of absolute threshold of 10 and a percentage threshold value of 5. Another partial function called percent anomaly detection is created using, again, the real-world anomaly detection function, this time with an absolute threshold of 5 and a percentage threshold of 10. We now have two partial functions, each with their own specific fixed parameter values that can then be used later on in this function for several use cases. Let's take things up a notch with some slightly more sophisticated examples in each of the three realms. In streaming log processing, we can simulate a multi-level, multi-format log processing system with conditional formatting, as you can see here, and other operations. In this example, the function hyperadvancedLog, for instance, can be configured with partial functions to handle complex scenarios such as encrypted error logs or simple information logs. In genome pattern detection, we can create a function called advanced genome pattern recognition, as is the case here, that considers both direct and reverse complement matches. This adds a layer of complexity and realism to our analysis and gives us a slightly more involved situation where a partial function is involved in a data processing task that you would likely find in a real-world scenario, not necessarily in the realm of genome pattern detection. And finally, in the last stock price anomaly detection example here, we can perform a multi-factor analysis. This allows for a slightly more nuanced approach to detecting anomalies, considering factors like historical volatility, for instance. And later on, two partial functions are created using this very multidimensional anomaly detection function with their own initialized prefixed parameter values. In conclusion, partial functions, as you can see, are a powerful tool, especially when dealing with repetitive tasks that require only some parameters to change. And this can make the code a lot more concise, readable, and efficient both from a performance as well as a readability perspective. That's all for this hands-on. See you in the next lecture.